Hello everyone, welcome back to the Tensor Maker channel. Here, we explore and build on decentralized AI. If you caught our last video on how to run Hypertensor on a Mac, that's great, but this time we're going to do it on Windows. Even if you're brand new to running terminal commands, I'm going to show you how easy it is to run a Hypertensor node on your Windows computer. I'll walk you through how to spin up a Hypertensor node on Windows Subsystem for Linux, or WSL for short, in a few easy steps. My name is Steven, and I've been working for 20 years in technology, from the early internet to modern AI systems. My goal is to help you own a piece of decentralized AI infrastructure, not just consume it. As a refresher, normally we don't earn from the networks that are out there, the mobile network, the internet network. We just consume or maybe build things on top of those networks. With decentralized AI systems like Hypertensor, you can actually run a node and earn tokens from that infrastructure. If you have a Windows PC, especially if you have one with an NVIDIA GPU or graphics processor unit, you can run Hypertensor. Let's go to the demo now. Here we go with the demo now, and we're going to show how to set up Hypertensor node on Windows Subsystem for Linux. And this is a simplified guide that I made. Always refer to the official Hypertensor documentation, which I've put in the description below. I've also put this cut and paste, easy step-by-step guide also in the description below. Now we're going to be running this in a version of Linux called Windows Subsystem for Linux, and it's built in. It's an underlying system in Windows that helps you more easily run Linux type-based software inside Windows. So first of all, we're going to do everything from the terminal, and we have to make a quick adjustment to the terminal to make it easier to cut from the guide and paste in the terminal. So we hit the Windows button and we type TER to get up the Windows terminal. And due to historical things, it's a little bit weird to cut and paste in the terminal, but we're going to right click on the taskbar, go down to Properties, and make sure that Use Control-Shift plus CV as copy and paste is on. So make sure this checkbox is toggled on. And the reason why we do that is then, in Windows, you copy and paste by using Control-C and Control-V. To make it work properly in terminal, you have to do Control-Shift-C, Control-Shift-V to make that work okay. So that's all set now, and we're ready to go. The first thing we have to do is make sure that Windows Subsystem for Linux is installed. By default, it's not installed, and that is pretty easy. You just type WSL install. Now, in my system, it's already installed. Normally what would happen is it would download it, it would install it after some time, and it would ask you to reboot the system. Okay, once it's rebooted and after Windows for Subsystem is installed, we go into the terminal again, TER, hit terminal, bring the new terminal window over, and then to enter into Ubuntu, we type Ubuntu. And it might take a minute to get up and running because it has to start up the Windows subsystem, but in my case, it's already running. So you type Ubuntu. The first time after installation, it'll ask you to put in a username and a password. So that's already been created. I have Tensor Maker as my username and my password. And so now we're running the Linux subsystem in the Windows terminal. So now what we need to do is we need to go through all these steps to install all the software that we need to run and build Tensor and to run it on our computer to build Hypertensor. So here we go. We're going to authenticate and get ready the package manager for the Linux subsystem, the Ubuntu subsystem. So we've done a Control-C on the document and a Control-Shift-V on the terminal. So we put in the password, and you'll see it'll download and check to make sure that all the packages are updated on the Windows subsystem, that the package manager is all updated. And here's what we're going to do. We're going to install some common software that is needed. That's already installed because I've done this before. Might take a little bit longer on your machine. And here we're going to install a package manager repository for Python. Now, Python's a language that is used to run the Hypertensor software. There is already a Python installed by default on Ubuntu, but we're going to be downloading a specific version which is Python 3.11. I had some trouble originally with using more modern versions of Python, the latest versions. They had some drivers issues and some issues with the Python Torch, PyTorch, which is the AI engine, but I have no problems running on 3.11. And now we're going to update all our repositories that we've added the one for Python, right? So that's updated. And now we're going to install Python version 3.11, and also we're going to install Git, which is the software that we need to download the Hypertensor software, the open source software from GitHub. So that's all been installed fine. We can also check to see if we've got the right versions, if we have Python, and if we have Git, and they're both installed. We have Python 3.11, at least that's what's current, and then this Git version. So also, if you happen to have an NVIDIA GPU, this laptop of mine actually has a older GPU in there, NVIDIA GPU. You can actually use this to help run the node quicker, to process the AI instructions quicker. So we're gonna install the NVIDIA CUDA, which is the language and the interface to the GPU. It is passed through. You have to also make sure that you have the drivers installed inside Windows, and this will allow you to pass them through to the Linux subsystem. So make sure that the CUDA drivers go to NVIDIA's website, make sure they're installed in Windows if you have an NVIDIA GPU, and then also we have to install these packages. So this one is installed, and we're just going to double check that everything's running okay. So cut and paste this command, this NVIDIA command, and it should come back showing that I have a NVIDIA GeoForce 2070 running on this laptop, and it has 8 gig of video RAM, VRAM. So that's cool, and that'll help us run our node quicker. So now we're going to get to the meat of downloading and running the Hypertensor software. So we Control-C there, Control-V, and we're making a directory called Tensor in our default directory. And then we're going to change directories into that Tensor directory. And this git clone command essentially downloads the software, the Hypertensor software, from GitHub. So let's clone it. It should come down really quick. And then we're going to enter that directory, DSN, and start building and running Hypertensor. DSN stands for Decentralized Subnet, and this is the current build of the software, the current repository where we're going to be running our AI decentralized node. So next step is to create a Python virtual environment. This keeps all the software that we're building in a separate sort of envelope or environment for Python, and it doesn't mess around with the default Python that is installed in the Ubuntu Windows subsystem Linux. And we're going to activate this sort of virtual environment to run our Hypertensor. We've enabled it, and we should see now that we're running version 3.11 because that's the one that we downloaded, activated, and installed. So there we go, Python 3.11. Now what we're going to do is we're going to create an environment file for the Hypertensor node. Because this is a blockchain-based Web3 project, what that means is normally we would have associated with that cryptographic wallet with some Tensor tokens associated with this account, with this node. And what that does is when you actually on mainnet add your node to the network, you have to have some sort of skin in the game. You are putting up some share of the Tensor tokens that you own, to say, hey, I'm going to be part of this network and to participate in the economy and the earnings. So it's like putting your vote in with some Tensor tokens. In this case, we are running on testnet. There's no real Tensor tokens involved in here. There's some sort of like fake testnet tokens. And normally you could get them from a faucet and put them into a web wallet. But the Hypertensor developers for this testnet have nicely made about 100 different accounts that are preloaded with these Tensor tokens, so we don't have to worry in this tutorial about the web wallet. We'll do that in a future tutorial before mainnet. So what this command is essentially doing is it's picking a random wallet between 1 and 100 and assigning that to our Hypertensor node. Also, this environment variable and file is telling us how to connect to the Hypertensor testnet. So we'll cut and paste this and run it, and let's see what the file looks like. So we just do cat command, and this will echo back what's in that file. So it's picked us lucky number 13 as our node. Let's see later on if somebody's already used that wallet or nobody has used it for our Hypertensor node. Now comes the fun part. We're going to install all the dependencies needed for Hypertensor in Python. So this will download all the Python libraries that are needed to run this. It's using pip, which is a package manager for Python. So we're going to make sure it's all installed. And then we're going to install all the dependencies for Hypertensor on our computer. So it's going to install everything as described in that bundle of files that we downloaded from GitHub. A lot of stuff you see flying by have to do with NVIDIA, have to do with other libraries that is used by Hypertensor to run the AI. Okay, that's all done now. You can see it downloaded and built everything that it needs to build. And we're going to run some of these modules in Python now. The first one is building a unique identifier for our node. It's building a public-private key, and it's going to assign us a unique identifier for our subnet node. So Control-Shift-V, and we run this Python command. And it should come back with our peer ID, which we'll use in the next step. Let me just get rid of this. Okay, so it'll give us the peer ID that we have to use next. Now we run to this command, which will be registering our node in the subnet network. Sorry, in the Hypertensor network. So Control-C. Okay, and this basically says that you're adding 1,000 token stake. And this, once again, shows you that we have to put skin in the game. These wallets have been preloaded with 1,000 tokens. And right here, we're going to delete where it says your peer ID. We're going to highlight our peer ID from the previous step, double click on it, Control-Shift-C, and then Control-Shift-V to paste on the command line and hit enter. So if we're lucky, nobody's used lucky number 13 yet, wallet 13, and we'll be able to add ourselves to the network. So let's go back and see what happened. And success. We've added ourselves to the network. So I have some instructions. If you have to see something like must unstake to register, you might have to delete the private key and run the environment commands again to get a different phrase, a different wallet, and then generate the private key again. So let's go back here. We're going to run this validator node now. Control-Shift-V. And what this is going to do is it's going to download the model, the AI model. In this case, it's using a variant of Llama, which is Meta's open weights. And this looks like it's been tuned to be uncensored. So it's going to download this orangutan model. It might take a while for the first time because it has to download it in, I think, 4 different chunks. It's a few gigabytes. It downloads it to your computer. After you have that downloaded, it's cached there, it's local, and then it's a lot faster to start up your server. So I've already downloaded it. It shouldn't take as long, but what it'll do is it'll start up, it'll connect to the network, and it'll load the blocks of this AI model into my node. So here we go. It's checking to see if my identity is unique and I'm not as one of the other peers that is already out there. So you can see that my throughput is being reported as being able to run 305 tokens per second. That's sort of like chunks of words that can be processed by my GPU. And then you can see that I'm loading the blocks of the AI model there. I think there's like 32 blocks, and we'll wait till it completes. Okay, now we can see that the blocks are all loaded, and we get the info in the log saying that it started. And it says that our server, our node, should be available on the dashboard, which I'll show you in a minute. So now there's one last command. We have to open another window and run the activate command. So don't forget this, or we won't be completely added into the network. So we're going to open up another terminal, which is the Windows key, TER, add it here, bring it over, and we need to type Ubuntu to activate this Linux subsystem. There we go, we've run it. And then we want to go to the directory where our Hypertensor software is locally. So we want to change directories. Whoops. And then we want to activate it. So we're activating here our Python environment because we have to run another Python command. So we have to be in our Python environment with that software activated. And then finally, we're just going to activate the node on the network. Whoops. Let's copy all this. And here you see that we have success. We've added and activated our node on the network. So that's great. Now, how do we know it's actually working? Well, there is a dashboard where we can go. It's in the gist and in the comments below and in the description below. Open that link up, dash.hypertensor.org, and you can see that there's a whole bunch of different peer IDs. These are all the different nodes that people are running on testnet. Now, if you click on this little button here, right of validators, you can see how much throughput, how many tokens per second they're able to process based on their different GPUs. And we can look up where ours is. So we go back again, we can scroll up here. And if you remember that we use this peer ID. So this one ends in VWEN. Let's look through here if we can find it. Here, VWEN. This is us. And we're running about 305 tokens per second. That's what my GPU is able to process. And if you look here, it may be a little bit limited, but you can see that we're showing up as a relay. Why do we have relay and everybody else is direct? Well, that's because I'm running this at home and I have my router, my home router has a firewall on it. So really, I'm able to send data out and communicate with the Hypertensor mesh network, all the different nodes, but they can't communicate directly back with my computer here unless I open some ports. And so what this means is I'm sending my data through one of these other nodes that is meshed to the whole network. And in a future video, I'll show how to run an always-on Hypertensor node in the cloud that we can open the ports and it can be directly meshed. And we'll try different cloud GPUs and see if we can get those tokens per second up and how much that would cost us to run a Hypertensor node in a cloud. So anyways, that's great. Looks like we're there. And then another test that we can do is we can actually test the chat. So if we go to chat.hypertensor.org, we can open it and we can see it's a normal chat interface like we're used to in any type of centralized AI or any other type of AI. So we can ask, what is Hypertensor? And then the AI assistant, this is sending our question out to the Hypertensor mesh and all the different nodes. And one of the nodes will pick up the request and respond back. It's a decentralized AI blockchain that enables the creation of a modular distributed framework for running AI workloads. And this one has been answered by W1FV. So if we look back here and find out who W1FV is, that is this one. So it's being answered by this node in the mesh, and that's pretty cool. And then we can go back and ask it any more questions we want, like, why is decentralized AI important? And you don't even need to spell or type properly. It will sort that out. And it's important because no central entity controls the AI infrastructure. It's fairness, transparency, and accessibility, and it's censorship resistant. And this is what we talked about in the first video. And at the end, you can go back and find that, and I explain why AI is important. So that's pretty much it then. We have now built and run a node on a Windows computer that is connected to the Hypertensor decentralized OpenAI network. And that's it. Now you're running Hypertensor on a Windows computer. You're officially part of the decentralized AI revolution, practicing on testnet and preparing for mainnet when the real Tensor tokens and rewards kick in. Thank you for watching, and if you like this video, comment below on what videos you'd like to see next. In future videos, I'm going to be showing how to run Hypertensor in the cloud in an always-on system. If you're interested in decentralized AI and why it's so important, and how systems such as Hypertensor can help fix centralized AI, watch this video above. And until next time, keep building on decentralized AI.